Dear students, very good morning and welcome to Electronic Devices and Circuits course. This is Dr. Y. Pandu Rangaiah, Associate Professor in the Department of Electronics and Communication Engineering, Institute of Aeronautical Engineering. And today's topic is the junction field effect transistor and its problems on parameter calculations. After completion of this session, the students will be able to solve the problems on JFET parameters, and they can also calculate the parameters of the drain resistance, transconductance, amplification factor, pinch off voltage, the drain source saturation current, the VGS, the transconductance at VGS equal to 0. All these are parameters and how to calculate, and we'll do that by doing some example problems. Let's move on to that. The first problem. In N-channel JFET, IDSS equal to 10 milliamperes and VP equal to minus 33 volts. Determine the drain current when VGS equal to minus 1.5 volts. So here given it is a junction field effect transistor of N-channel, where it is of having the drain source saturation current is 10 milliamperes, 10 into 10 power minus 3 amperes, and given the pinch off voltage equal to minus 33 volts, and VGS is equal to minus 1.5 volts, and is asking us to calculate what is a drain current. To calculate the drain current, we have the expression ID equal to IDSS into 1 minus VGS divided by VP whole square. So this is the equation which we derived from the transfer characteristics of an N-channel junction field effect transistor, where here VGS, VP, IDSS values are given and we need to calculate the ID. So here we will substitute all these values. The ID equal to IDSS into 1 minus VGS minus 1.5 volts divided by VP minus 33 volts and whole square. So, and we'll simplify this equation and we'll get it is and what is the value of ID current. So this equation which gives the relation between IDSS, VGS and VP, this equation is called as an Shockley's equation. Shockley's equation in case of junction field effect transistors. So by using this equation, we can calculate the drain current by knowing these and other parameters. Right? So we'll move on to that. The next problem. The N-channel JFET has IDSS equal to 20 milliamperes, pinch off voltage VP equal to minus 8 volts, and GMO equal to 5000 microsiemens. Determine the values of the transconductance at VGS equal to minus 4 volts. So to solve this the problem where it had been given it is an IDSS. IDSS is equal to 20 milliamperes. Given the pinch off voltage VP equal to minus 8 volts, the transconductance GMO equal to 5000 microsiemens, and is asking us to calculate the value of the transconductance at VGS equal to minus 4 volts. What is the value of GM? So to calculate this, the GM, where we need to know that what is the expression of the GM, we can calculate in terms of the GMO. So to calculate that, first we will derive that what is the relation between that. To derive that the relation between the GM and GM naught, let us consider the equation, the Shockley's equation, which we have ID equal to IDSS into 1 minus VGS divided by VP whole square, which is called as an Shockley's equation for JFETs, where we know that from the transistor or junction field effect transistors, the parameters of JFET parameter of the transconductance, which is defined as the ratio of change in ID to change in VGS by keeping VDS is equal to constant. This is from the definition where we can calculate from the transfer characteristics of a JFET, the transconductance, which is given by it is a ratio of the drain current to gate source voltage by keeping VDS is equal to constant. This also I can write it is an GM equal to change in ID, I can write it is an dou ID divided by change in VGS, I can write dou VGS. Or if I substitute the expression for the ID current here, then I can write the dou by dou VGS of ID expression, I can write IDSS into 1 minus VGS divided by VP whole square. If I differentiate this, then I can get GM equal to 2 IDSS is the constant. The differentiation of 1 minus VGS by VP whole square, I can write 2 into 1 minus VGS divided by VP. And the differentiation of again 1 minus VGS divided by VP is nothing but 0 minus 1 divided by VP. This I can write GM equal to 2 IDSS divided by minus VP into 1 minus VGS divided by VP. Or here I will consider it as an GMO, I will consider as 2 IDSS divided by the magnitude of VP. I will consider it as an GMO. Therefore, this expression I can write GM equal to GM naught into 1 minus VGS divided by VP. So, this is the expression which is used to calculate the transconductance by knowing the GMO. So, where the GMO is given, VGS is given, the VP is given. So, we can start to apply all those values here in this expression and we can calculate what is the value of the GM. So, therefore, the GM equal to, I can use this equation to calculate for this expression. So, the GM equal to GM naught, which is given as an 5000 into 10 power minus 6 Siemens into 1 minus VGS is asking us to calculate it VGS equal to minus 4 volts divided by VP is minus 8 volts. So, where the minus will be gets cancels and again it is an 4 2s or it is 1 minus 1 by 2 where it is 5000 into 10 power minus 6 into 1 minus half which is nothing but the half or it is GM equal to 2 times 2500 into 10 power minus 6 Siemens or it is GM equal to 2500 micro Siemens. This is how we can calculate. So where from this expression we got it is the relations between the transconductance GM and as well as GM naught. Where the GM naught is 2 IDSS divided by magnitude of VP or the GM equal to GM naught into 1 minus VGS divided by VP. Okay. So rest of all the problems are in similar kind of calculating by knowing these three expressions. So here the important expressions of calculating the JFET parameters, the problems are, these are the three equations. One equation is ID equal to IDSS into 1 minus VGS divided by VP whole square, which is called as the Shockley's equation. Other one it is which gives the relation between the transconductances, where it is GM equal to GM naught into 1 minus VGS divided by VP. The third one is how to calculate the GM naught by knowing IDSS and the pinch off voltages, where the GM naught equal to 2 IDSS divided by the magnitude of pinch off voltage. So all the problems of JFET parameters belongs to that pertaining to these three expressions. Okay, let's move on to the next problem. Determine the transconductance of JFET if its amplification factor is 94 and the drain resistance is 30 kilo ohms. So here this problem is asking us to calculate what is the transconductance, the GM of an JFET, if its amplification factor, which is denoted with mu, equal to 94 and the drain resistance small rd equal to 30 kilo ohms or it is 30 into 10 power 3 ohms. So these are the three parameters of JFET. One is the transconductance, the second one is the amplification factor and the third one is the drain resistance. There is a relation between among these three JFET parameters. That relationship is given by mu is equal to GM into RD. This is the relation between the JFET parameters of amplification factor, transconductance, and drain resistance. So given mu and RD and is asking us to calculate the GM. So therefore the GM is equal to mu divided by RD. Mu is given, it is an 94 and divided by RD is nothing but 30 into 10 power 3. Or it is 94 divided by 30 into 10 power minus 3 Siemens. So using this, we can calculate what is the transconductance. So apart from that, those three equations which we discussed in the previous problem, this is another equation where mu is equal to GMRD, which gives the relation between the JFET parameters of amplification factor, transconductance, and as well as drain resistance. We'll move on to the next problem to do that. A JFET has the parameters of VGS of, which is the threshold voltage, is minus 10 volts, or IDSS equal to 6 milliamperes, and determine the ID for the device by using VGS is equal to 0 volts. So when VGS is equal to 0 volts, the drain current ID is the maximum current, which is called as the IDSS. If you look at it for N-channel JFET transfer characteristics, the transfer characteristics is a graph between ID versus VGS. Just I am drawing it is the transfer characteristics of a graph of N-channel JFET, where it is a graph between ID versus the VGS. When VGS is equal to 0 volts, ID equal to maximum, which is called as an IDSS. As the VGS is increases negatively for N-channel JFET, the drain current will be go on decreases and it will becomes to the 0. And this voltage at which the gate source voltage at which the drain current will be becomes to 0, which is called as an VGS off, or it is also called as an pinch off voltage. Pinch off voltage. Once again, I'll repeat. The gate source voltage at which the drain current becomes to 0 is called as an pinch off voltage. Whereas the gate source voltage is at 0 volts, the drain current will be attains to its maximum value, which is called as the drain source saturation current. So here in this problem is asking that the drain current at VGS equal to 0 volts. It means that what is the maximum drain source saturation current. Therefore, at VGS equal to 0 volts, ID will be attained to its maximum value of IDSS. Therefore, the answer for this problem is 6 milliamperes at VGS equal to 0 volts. Right? Let's move on to the next problem. Determine the value of GM for a JFET. If IDSS equal to 8 milliamperes, VP equal to minus 5 volts, when it is biased at VGSQ equal to VP by 4. So what is asking us to calculate? The transconductance GM. When IDSS is equal to 8 milliamperes and VP equal to minus 5 volts, and when it is biased by VGSQ equal to VP divided by 4. So to calculate the GM, we have the expression is GM equal to GM naught into 1 minus VGS divided by VP. And again to calculate the GM naught, we have the expression GM naught equal to 2 IDSS divided by magnitude of VP. So from this, I will calculate what is GM naught, and later on I can substitute this. GM naught equal to 2 IDSS, 2 into 8 milliamperes, 2 into 8 into 10 power minus 3, divided by the magnitude of VP, which is nothing but the 5. Or from this, we can get it is an GM naught equal to 16 divided by 5 millisiemens, right? Therefore, the GM equal to GM naught 16 by 5 into 10 power minus 3 into 1 minus VGS divided by VP, where the VGS is given it is an VP divided by 4 into VP, or it is 1 minus VP will be gets cancels. 1 minus 1 by 4, where it is GM equal to 16 divided by 5 into 10 power minus 3 into 1 minus 1 by 4, which is equal to 4 minus 1, it is 3 divided by 4. So this, it is Siemens. With this expression, we can calculate what is the GM, right? Next, we'll move on to the next problem. Calculate the GM naught for an junction field effect transistor having the parameters of IDSS is equal to 15 milliamperes and the pinch off voltage VP equal to minus 5 volts. Where we know here the relation between the GM naught, IDSS and VP as GM naught equal to 2 IDSS divided by magnitude of VP, where it is equal to 2 into IDSS 15 milliamperes divided by the magnitude of VP is 5 volts, or it is an 5 into 3, or it is an 6 millisiemens GM naught equal to, right? So once if you know that those are formulas and it is easy to calculate, these are problems pertaining to that JFET parameters. So we'll move on to the next problem. Determine the pinch off voltage of a JFET with GM naught equal to 10 millisiemens and IDSS equal to 12 milliamperes. Pinch off voltage we need to calculate, where given is GM naught equal to 10 millisiemens and IDSS equal to 12 milliamperes. So same relationship, GM naught equal to 2 IDSS divided by the magnitude of VP, or magnitude of VP equal to 2 into IDSS 12 milliamperes divided by GM naught 10 into 10 power minus 3 Siemens. 10 power minus 3 will be gets cancels, or magnitude of VP equal to 24 divided by 10, or it is an 2.4 volts. Okay, this is how we can calculate the pinch off voltage from the same expression by knowing the GM naught and IDSS. Let's move on to the next problem. For a FET having the device parameters of, given it is GM naught equal to 5 millisiemens and the pinch off voltage VP equal to minus 3.5 volts, and what is the device current ID when VGS equal to 0 volts. And in the previous problem, I have been explained that when VGS is equal to 0 volts, the drain current will be attains to its maximum value, and that drain current is given by ID equal to IDSS. That is, at VGS is equal to 0 volts, ID equal to IDSS. So to calculate the IDSS, we have the relation is GM naught equal to 2 IDSS divided by magnitude of VP. Or from this, IDSS is equal to, I can write GM naught into VP, magnitude of VP divided by 2, where given the GM naught is equal to 5 into 10 power minus 3 and the magnitude of VP is 3.5 divided by the 2. So using this expression, we can calculate this is 5 into 3.5, 15 plus 2.5, it is 7.5 divided by 2 into 10 power minus 3 IDSS. So it is 17.5 divided by 2. So to 8 and to 7 and 5 milliamperes. So this is the value of IDSS, where ID is at VGS equal to 0 volts, ID equal to IDSS. Therefore, the drain current ID equal to 8.75 milliamperes. Right? Next, we will move on to that next problem. Calculate the value of the GM of a JFET having IDSS is equal to 12 milliamperes, 12 into 10 power minus 3 amperes, where the pinch off voltage VP equal to minus 3 volts and at a bias point of VGS is equal to minus 1 volt. So I need to calculate the GM. To calculate the GM, we have the expression GM equal to GM naught into 1 minus VGS divided by VP. Whereas the GM naught is not given. Therefore, to calculate the GM naught, we have the expression GM naught equal to 2 IDSS divided by the magnitude of VP. Therefore, the GM naught first we can calculate by using this expression, substituting the values, where the 2 into IDSS divided by magnitude of VP is nothing but the 3. Or it is GM naught equal to 3, 4, 4 to the 8 millisiemens GM naught. By knowing this value, therefore, GM equal to GM naught 8 into 10 power minus 3 into 1 minus VGS minus 1 divided by VP minus 3. Or it is minus will be gets cancels. Or it is a GM equal to 8 into 10 power minus 3 into 1 minus 1 by 3. So 3 minus 1 it is 2 divided by 3. Or it is 16 by 3 into 10 power minus 3. Or it is 5.33 millisiemens. This is how we can calculate GM by knowing all other parameters. Where is not given the GM naught. The GM naught we can calculate by using this expression and substituting in this, and we got this and the GM. Let's move on to the next problem of similar kind. For a JFET of having GM is equal to 6 millisiemens and where the VGSQ equal to minus 1 volt. What is the value of IDSS? Means what is the drain source saturation current if VP equal to minus 2.5 volts, which is of same kind of the previous problem where we have to calculate the IDSS. To calculate the IDSS, where we have GM naught equal to 2 IDSS divided by magnitude of VP. But we don't know that what is an GM naught. To calculate the GM naught, we have GM equal to GM naught into 1 minus VGS divided by VP. Where from this, the GM is given 6 into 10 power minus 3 Siemens. GM naught not known. 1 minus VGS, I know it is an minus 1 volt given. VP minus 2.5 volts is given. So therefore, from this 6 into 10 power minus 3 equal to GM naught into minus becomes and 2.5 minus 1, it is an 1.5 divided by 2.5. Or it is from this, the GM naught equal to 6 into 10 power minus 3 into 25 divided by 15, or it is 5 divided by, or it is 2 times, or it is GM naught equal to, I can write 10 into 10 power minus 3 Siemens. So once if I know that the GM naught, I will substitute this value here, 10 into 10 power minus 3 equal to 2 IDSS divided by magnitude of VP. It is an magnitude of VP is 2.5. Or if it is IDSS, from this, IDSS is equal to 10 into 10 power minus 3 into 2.5 divided by 2. Or it is IDSS is equal to 10 into 2.5, 25 divided by 2, which is nothing but 12.5. 10 power minus 3 milliamperes. So this is how we can calculate the IDSS by knowing the other parameters. Right? Thank you. And these are the learning resources to do that the more exercise problems and follow this Boyle State textbook, and where we have designed more exercise problems of similar kind. So to summarize that, in this session, we discussed about the problems we did on junction field effect transistors and its parameters, where there are the 4 equations which are main to calculate the other parameters, which are, first equation is the drain current ID equal to IDSS into 1 minus VGS divided by VP whole square, which is called as the Shockley's equation. and where the next equation is which gives the relation between the GM and GM naught, the transconductances, where the GM equal to GM naught into 1 minus VGS divided by VP, where the GM naught is 2 IDSS divided by the magnitude of VP, and there is the last equation which gives that the relation between the JFET parameters, which is mu equal to GM RD, where mu is called as an amplification factor, GM is the transconductance, RD is the drain resistance. So by knowing these 4 equations, and if some parameters are given, the other parameters we can start to calculate. So this is about the problems on JFET parameters. Thank you, and again we'll meet in the next session. We'll do the problems on JFET amplifiers. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.